In this video, we will be covering chapter 3, which is coordinate geometry from the textbook. And the whole idea of this chapter is to find a system or a mechanism to locate a point on a flat surface. Suppose we have a piece of paper, and on the piece of paper there is a point that is marked, and we want to have a system to represent that point in a unique and unambiguous way without causing any confusion. We have to we should be able to represent that point using some representation that uniquely identifies that point. But before we go into that representation of a point on a flat surface or a piece of paper or on the top of a table or something, let us recall what we have seen in chapter 1, where we saw the number line and how to locate points on the number line. So the number line has a reference point which we call as the origin, and from the origin we have other points which are at certain distances from the origin. Now the unit distance from the origin, okay, the unit distance means a single distance from the origin is represented by the number 1. That means then that the 2 unit distances will represent the number 2, 3 unit distances will represent the number 3, and so on and so forth. So these numbers which are going in one direction, that is to the right hand side of the origin, these are all the positive numbers which are represented on the number line. So 1 is on the right side of the origin, similarly 2, which is plus 2, on the right side of the origin, and so on and so forth. But if we have the points at equal distances on the other side, but in the opposite direction of the origin, instead of on the right side of the origin, if we have them on the left side of the origin, 1 unit distance on the left side of the origin represents the number -1. 2 unit distances on the left side of the origin is representing -2, and so on and so forth. So we have all the positive numbers on the right side of the origin and all the negative numbers represented on the left side of the origin, and the origin itself is representing the number 0. Now a situation will arise where we just don't have to represent the points on a single line. So on the number line here, each of these points is being represented on the line itself. So for example, this point is represented by the number 2. So this point has a distance of 2 units from the origin, and it lies on the number line itself. Similarly, we can have another point, let's say this point which I'm marking with a red dot here, and that point is at a distance of 4 units from the origin but to the left hand side, so therefore that point is represented by the number -4 on the number line. But what we notice is that all these points are lying on the line itself, on the number line itself. Now we will extend this idea to represent points not on the line itself but on a flat surface like a piece of paper. So if we have a piece of paper and there is a point marked on that piece of paper, how do we represent that point on that paper uniquely without causing any confusion? So as we have here in this particular diagram, so it's we have a piece of paper on which we have a point marked on it. So how do we represent this point in a unique way so that it does not confuse with any other point on the paper? So one way of doing it is to represent that point using the distance of that point from the left vertical edge and the bottom horizontal edge. How far is that point from the left vertical edge? So the distance from the left vertical edge to the point, that represents one particular coordinate. So let's say it is 5 centimeters. So we say the point is 5 centimeters from the left vertical edge of the paper. And similarly, the point lies at a distance of 9 centimeters from the bottom horizontal edge of the paper. So we can represent this point using these 2 numbers, but with the reference that the 5 centimeters represents the distance from the left vertical edge and the 9 centimeters represents the distance from the bottom horizontal edge. So that way we will be able to represent the point in a unique way. So if there is any other point, let's say we have another point somewhere here, so we can say that that point is having a certain distance from the left vertical edge. So if this is 5, maybe this is say 7 units. So we can say it is having a distance of 7 centimeters from the left vertical edge, and it has some other distance which we can represent from the bottom horizontal edge. And let's say that distance is equal to, if this is 9, let's say this is something like 12. Okay, so we'll say this is 12 centimeters. Okay, so by using the reference edges, we can represent each and every point in a unique way based on the distance of that point from each of those reference edges. And this is what we are going to develop in coordinate geometry. So we will use two reference lines to represent our points uniquely. Just we have a single reference line, which is the number line, to represent points on the number line. Now we are going to use two number lines. One number line is going to be horizontal and the other number line is going to be vertical. And using these two number lines, we will be able to represent the points on that flat piece of paper or on any flat surface on which that point is lying. So we are going to have a representation based on something like this, where we have a number line which is horizontal and another number line which is vertical. So basically the coordinate system that we are going to develop is going to be based on two number lines which are perpendicular to each other. So the horizontal line and the vertical number line are 90 degrees with respect to each other. So we say that the two number lines are perpendicular to each other. So the horizontal number line has the origin, which is marked by the letter O. So the origin is the point of the zero value, and we have the numbers to the right of the origin, which are positive numbers. 1 unit distance from the origin is the number 1, 2 unit distance from the origin is the number 2, and so on. So all the numbers on the right hand side are positive numbers. So we call this as the positive x-axis. The horizontal line, we will now call it as the x-axis. And similarly, the numbers on the negative side or the left hand side of the origin will be denoted with a negative sign. So we have 1 unit distance to the left of the origin represented by the number -1. 2 unit distances to the left of the origin is -2, and so on and so forth. So we call this as the negative x-axis. So the entire horizontal number line is called as the x-axis. The numbers lying on the right side of the origin, we will denote those as belonging to the positive x-axis, and the numbers lying on the left hand side of the origin, they will belong to the negative x-axis, because they are all negative numbers, and on the positive x-axis we have all positive numbers. Similarly, we have the vertical number line, where again the origin of the vertical number line meets the origin of the horizontal number line, and all numbers which are above the origin, they are positive numbers, and all numbers on the vertical number line which are below the origin, they are negative numbers. So a point 1 unit distance from the origin above the origin is represented by the number +1, 2 unit distances is +2, and so on and so forth. Similarly, if you have points below the origin, 1 unit distance from the origin is -1, 2 unit distance from the origin is -2, and so on and so forth. So therefore we have the vertical number line represented or called as the y-axis, and all the numbers which are positive or lying above the origin of that number line, we call that part of the y-axis as the positive y-axis, and all the numbers on the positive y-axis are positive numbers. Similarly, all the numbers which lie below the origin, or the part of the y-axis which lies below the origin, is called as the negative y-axis, and all the numbers or points that lie below the origin are represented by negative numbers. Hence, we call this as the negative y-axis. Now, using these two axes, the x-axis and the y-axis, we will be able to represent any particular point on the flat piece of paper or on any flat surface. We call such a flat surface as a two-dimensional plane. So we have one horizontal dimension and another vertical dimension, and on a two-dimensional plane which has a horizontal and vertical dimension, we will be able to represent any point using these numbers which lie on the x-axis and y-axis. Okay, and such a representation is what is called as the Cartesian coordinate system. Okay, so let me write that. So such a way of representing a point using two number lines. So we have the x-axis, which is the horizontal number line, and the y-axis, which is the vertical number line. And when we use these two number lines to represent our points, such a system of representation is called as the Cartesian system. And in this chapter of coordinate geometry, we are going to focus on this particular representation called as the Cartesian system. It is named after the mathematician called René Descartes, who developed this system. Okay, so it's called as the Cartesian system. Now, the point where the two number lines intersect is called as the origin. So that origin is this particular point here, which is denoted by the letter O. We call that as the origin. And then we have the positive x-axis denoted by the number line OX. Similarly, OY is the positive y-axis. Okay, on the positive x-axis, all the x-axis numbers are positive numbers. On the positive y-axis, all the y-axis numbers are positive numbers. Similarly, we have OX dash as the negative x-axis. So all the x-axis numbers on the negative x-axis are negative numbers. And then we have OY dash as the negative y-axis. So we have the representations for the axis, which is the positive x-axis, positive y-axis, negative x-axis, and negative y-axis. And then we have the point of intersection of the two axes denoted by the letter O, and it's called as the origin. The next term that we should understand is what is called as the quadrant. Now, if we have the two number lines, the axis, the x-axis and the y-axis, so we have x dash x is our horizontal number line, which is the x-axis, and y dash y is the vertical number line, which is the y-axis. And we notice that these two number lines, when they intersect, they divide the entire plane into four quarters. So starting from the positive x-axis, we go in the counterclockwise direction, and each path is represented by what is called as a quadrant. So starting from OX, if we go in the counterclockwise direction, between OX and OY, whatever points lie in that space, that space is said to be as quadrant number 1. It's called the first quadrant. Similarly, all the points which lie between OY and OX dash, so OX dash is here, so all the points which lie in this particular space here, that space is called as the second quadrant or quadrant 2. So we are going in the counterclockwise direction from OX. So the first quadrant is between OX and OY. The second quadrant is between OY and OX dash. And we continue going in the counterclockwise direction. So we get the third quadrant between OX dash and OY dash. So that's our third quadrant. And we will have the next quadrant, which is the fourth quadrant, which lies between OY dash and OX. So the entire plane is divided into four quadrants called as quadrant 1 or first quadrant, quadrant 2, quadrant 3, and quadrant 4. So our points may lie in any of these quadrants, or our points may also lie on the axes themselves. So we may have a point lying on the positive x-axis itself, or we may have some point lying on the positive y-axis or the negative axis, x-axis, or the negative y-axis. But if it lies in any of those quadrants, then that point is said to be located in that particular quadrant. So we have four quadrants: the first quadrant, second quadrant, third quadrant, and the fourth quadrant. So therefore, what we see is that the entire flat plane, the flat surface, which we call as a plane, it consists of the two axes, the x-axis and the y-axis. Axis AXIS is a singular and AXES is the plural for the word axis. So there are two axes, x-axis and y-axis, and there are four quadrants. So the entire plane consists of two axes and four quadrants. And the plane represented in this way, it is called as, or the plane represented using two axes and four quadrants, is called as the Cartesian plane, or it is also called as the coordinate plane. And another name is the XY plane, because we are representing the plane using the x-axis and the y-axis, so it's also called as the XY plane. The axes themselves are called as the coordinate axis, so because they are going to represent the coordinates of the points on that plane. Okay, so we will see what do we mean by the coordinates. So the x-axis and y-axis, they are in this particular representation, they are called as the coordinate axis. So let us now see a quick illustration of how to represent a point on the Cartesian plane or the XY plane. So here we are trying to represent the points P and Q on these Cartesian coordinates or the Cartesian plane. So the way to represent each of these points is to have two numbers associated with it. The two numbers, we call them as the coordinates of the point. So each point is represented by two coordinates. The first coordinate is called as the x coordinate and the other coordinate is called as the y coordinate. Now what is the x coordinate and what is the y coordinate? The x coordinate is the perpendicular distance of the point from the y-axis. So if we have the point P, what is the perpendicular distance of this point from the y-axis? So it is this particular line here. So Pn is the distance of this point from the y-axis, and that denotes the x coordinate. So basically the Pn is going to be the same as OM here. So because it forms like a rectangle here, so the opposite sides will be equal. Excuse me. So whatever is Pn, OM is also going to be the same. So we will have the x coordinate as the distance of the point from the origin to the point M. So basically, in other words, it is the x coordinate denotes the vertical intercept of the point with the x-axis. So if we make an interception of the point vertically or perpendicular to the x-axis, it intersects with the number 4 on the x-axis number line. So the x coordinate of the point P is 4. Similarly, the y coordinate is the perpendicular distance of the point from the x-axis. So the distance of the point from the x-axis is this particular line, so which is ON, which is PM, that is equal to ON. But ON is basically giving us the intercept or the intersection of the perpendicular line from the point P to the y-axis. So if we extend a line from the point P to the y-axis, perpendicular to the y-axis, that line meets the y-axis at this number 3 on the vertical number line. So we say that this 3 is the y coordinate of the point P. So basically, we represent each point by two coordinates. One is called as the x coordinate and the other is called as the y coordinate. So the x coordinate is the intercept of the point P with the x-axis. So if we draw a perpendicular line to the x-axis from the point P, that vertical line intersects the x-axis at a certain point on the x-axis number line. So that gives us the x coordinate. So the x coordinate for the point P is going to be 4. Let me use a different color here. For the point P, the x coordinate is the number 4, and the y coordinate is the intercept of the vertical line between the point P and the y-axis. So that intercept is the number 3 on the vertical axis. So the y coordinate will be 3. So we represent these numbers in a bracket. So the point P is denoted by the x and y coordinates. The x coordinate is 4 and the y coordinate is 3. So in general, we represent the coordinates of a point in the form of the x coordinate comma the y coordinate. So we call it as x comma y. So the x coordinate for the point P is 4 and the y coordinate for the point P is 3. So we have the coordinates for the point P given as 4 comma 3 within the round brackets. Okay, so similarly we can find what are the coordinates for the point Q. So the x coordinate for the point Q is from the point Q, if we draw a perpendicular line to the x-axis and see where it meets on the x-axis number line, that will give us the x coordinate for the point Q. So from Q, we are going to draw a perpendicular line meeting with the x-axis. So that perpendicular line meets the x-axis at a point R, which corresponds to the number -6 on the x-axis. So the x coordinate of the point Q is going to be -6. So we'll write the point Q as having an x coordinate of -6, and the corresponding y coordinate for the point Q is when we extend a line from the point Q to the y-axis, perpendicular to the y-axis, and see where it meets the y-axis. It meets the y-axis at the point S, and the point S corresponds to the number -2 on the y-axis. So the y coordinate for this point Q is -2. So we have -2 over here, and we put them in the brackets. So the x coordinate for the point Q is -6. So x comma y is the general way of writing it. The x coordinate is -6 and the y coordinate is -2. So this is a way of representing a point using the Cartesian coordinate system. So where we use the x coordinate and y coordinate to represent each point. So again, just to reiterate and to make things clear, the x coordinate is obtained by extending or drawing a line from the point P to the x-axis, perpendicular to the x-axis, and see where it meets the x-axis, at what number it meets the x-axis. That gives us the x coordinate. Similarly, the y coordinate will be the perpendicular line from the point P to the y-axis, and wherever on that y-axis or on whichever number it intersects, that gives us the y coordinate for the point. So we represent the points on the Cartesian plane using the xy coordinates of the point. So the x coordinate and the y coordinate give us the exact location of the point on that plane, which we call as the Cartesian plane or the coordinate plane or the xy plane. So we see we have three names for here: Cartesian plane, coordinate plane, or xy plane. It is called coordinate plane because we are representing points on the plane using the coordinates, and we are using the x and y coordinate values. So it is also called as the xy plane. So this is the basic way of representing points on a plane using the Cartesian plane system or the coordinate plane system. Okay, and another piece of definition here is that the x coordinate is also called as the abscissa. So I'm going to write that here. So x coordinate, I'll write it in bracket here, is also called as abscissa. ABSCISSA. That's called abscissa. And the y coordinate has another name for it. It's called as the ordinate. ORDINATE. Okay, so we have another term for the x and y coordinates. The x coordinate is called as the abscissa, and the y coordinate is called as the ordinate. So 4 for the point P is the abscissa, and 3 for the point P is the ordinate. Similarly, -6 is the abscissa for the point Q, and -2 is the ordinate for the point Q. Okay, so that's another name basically for the x and y coordinates. X coordinate is called as abscissa, and the y coordinate is also called as ordinate. Let us now do a few examples of representing points on the Cartesian plane. And we have this diagram here where we have 4 points, the point B. So let me mark all those points clearly in red. So we have the point B over here. Then we have the point M over here. And then we have the point L and the point S. Okay. So we are now supposed to find what are the coordinates of each of those 4 points. So let us go one point at a time. So let's start with the point B and determine what is its x coordinate or abscissa and what is its y coordinate, which is also called as ordinate. Okay, so the x coordinate for the point B is basically the point where the vertical line or the perpendicular line from the point B to the x-axis intersects. So we see that the point B, if we draw a line perpendicular to the x-axis, where does it meet on the x-axis? It meets at the number 4. So each unit distance is representing a number 1. So 1 unit distance is number 1, 2 unit distances is 2, 3 unit distances represent from the origin and the number 3. So 4 unit distances, so that's 1, 2, 3, 4. That's 4 steps. So it represents a distance of 4 from the origin. So that point here, if you draw a line perpendicular to the x-axis from the point B, it meets at the number 4. So that means the x coordinate of the point B is 4. So x coordinate is also called as abscissa. So the abscissa for the point B is 4. Similarly, the y coordinate for the point B will be obtained or can be obtained by drawing a line perpendicular to the y-axis from the point B. So from B, if we draw a line perpendicular to the y-axis, we see that that particular line meets the y-axis at the number 3. So that means the y coordinate for the point B, which is also called as the ordinate, the y coordinate is also called as ordinate, that is equal to 3, because the perpendicular line from the point B to the y-axis meets the y-axis at that number 3. So therefore the ordinate is 3 for the point B. So therefore the coordinates of the point B, which we denote as x comma y, so the x coordinate is 4 and the y coordinate is 3. So therefore we will get this point B represented as 4 comma 3, which is x comma y. So x coordinate is 4 and y coordinate is 3. The x coordinate is also called as abscissa, and the y coordinate, which is 3, is called as the ordinate. Okay, so the point B can be represented by the representation 4 comma 3. So I'll write it here. It's 4 comma 3. So the x coordinate is 4 and the y coordinate is 3. So now let's do the example for point M and see what are the x and y coordinates for the point M. So let's see. For the point M, the x coordinate can be obtained by drawing a line from the point M perpendicular to the x-axis. So when we draw a line from M to the x-axis, perpendicular to the x-axis, we see that it meets that x-axis, that particular line meets the x-axis at the number -3 on the x-axis. So that means the x-coordinate for the point M is -3, or in other words, the x-coordinate, which is also called as the abscissa, is -3 for this case. So for the point M, the x-coordinate or abscissa is -3, and the corresponding y-coordinate for the point M is obtained by drawing a line from M to the y-axis perpendicular to the y-axis, and we see that the perpendicular line from M to the y-axis meets the y-axis at the number 4. So therefore the y-coordinate is equal to 4, or the ordinate is equal to 4. So from this we can now represent the coordinates of the point M as -3 comma 4, where -3 is the x coordinate. Let me write that x properly, and +4 is the y coordinate, so it's x comma y. Okay, so we have the coordinates of the point M as well in this way. And let's apply the same rules to the other 2 points. So we have the next point, which is point L. Let me write the coordinates for the point M on the graph as well. So the coordinates for the point M on the graph is minus 3 comma 4. So the x coordinate is minus 3 and the y coordinate is 4. So this will be denoted as minus 3 comma 4. So now coming to the point L, the x coordinate for the point L is the intersection of the line from L perpendicular to the x-axis. So we have the x-axis here. So when we extend a line from L to the x-axis, perpendicular to the x-axis, we see that it meets the x-axis at the number minus 5. So the x coordinate for the point L is minus 5. So we'll write the x coordinate, which is also called as abscissa, as minus 5. And the y coordinate of the point L is the point where the perpendicular line from the point L to the y-axis meets the y-axis. So we see that the line from L to the y-axis meets the y-axis at minus 4. So the y coordinate is minus 4. So the coordinates of the point L can be now mentioned as minus 5 comma minus 4. So it's minus 5 comma minus 4. So we have the x coordinate as minus 5 and the y coordinate as minus 4. So now that's the coordinate representation of the point L, which is minus 5 comma minus 4. So minus 5 denotes the x coordinate and minus 4 denotes the y coordinate for the point L. So let's write that down on the graph. So the point L is denoted by the coordinates minus 5 comma minus 4. Okay, so that's our coordinates for the point L. So now coming finally to the point the point S, we have, what is the abscissa for the point S? So the line from S to the x-axis intersects the x-axis at the number 3. So the x coordinate of the point S is going to be 3. So we see that's the x-axis. So when we extend a line from S to the x-axis and perpendicular to the x-axis, we see that that particular line meets the x-axis at the number 3. So the x-coordinate for the point S is 3. So x-coordinate again is also called as the abscissa. So the abscissa is equal to 3. So abscissa is 3. And similarly, the y-coordinate for the point S is the number on the y-axis where the line from S to the y-axis meets the y-axis. So when we extend this line from S to the y-axis, we see again that it meets the y-axis at the number minus 4. So the y-coordinate for the point S is also minus 4. So the ordinate, which is another name for the y-coordinate, is minus 4. So therefore the coordinates of the point S will be 3 comma minus 4. So 3 is the x coordinate and minus 4 is the y coordinate. So x comma y is 3 comma minus 4 for the point S. So we can write that on the graph as well. So for the point S, the x coordinate is 3. So that's 3 comma minus 4. Okay, so we now see how we can represent various points on the coordinate plane or the Cartesian plane, or also called as the xy plane. So this entire plane here that we have on this graph paper, that is called as the coordinate plane or Cartesian plane or the xy plane, and we will be able to represent any point on this xy plane. Now what we can do is we can, just as we had the points given to us and from the points we obtained what are the coordinates of those points, we can give the coordinates and try to mark those points on the graph or on the xy plane. So now that we have obtained the coordinates of these 4 points, B, M, L, and S, let us mark some more points on the same graph, and we will get a clearer understanding as to how to represent points on the coordinate plane or the Cartesian plane. So we have the same graph here. We have our existing points B, M, L, and S. On this, we are going to mark some more points on the plane. So the first point that we want to mark is 2, 2. So we want to mark the point 2, 2. The x coordinate is 2 and the y coordinate is also 2. So the way to do this is, the first coordinate is the x coordinate. So on the x-axis, we go to 2. And on the y-axis, we go to 2 and see where that those two coordinates. So we go 2 units on the x-axis and then 2 units on the y-axis. So basically what we do is we start from the origin, okay, and the first coordinate is the x-coordinate. So we go on the x-axis to the point 2, the x-coordinate, and from there we go we jump up in the y direction or jump up or down depending on the value of the y coordinate. The value of the y coordinate is 2 here without the minus, so we go in the upward direction to 2 on the y-axis. So we will get the point here. I'll mark these as crosses. So the point here, so that's our 2, 2. What we see is that the x coordinate for that point is 2 and the y coordinate for that point is also 2. So that's our point 2, 2. Okay. Similarly, for minus 1, 3, we start from the origin and we go on the x-axis to the point minus 1. So because it's minus, we go on the x-axis in the opposite direction. For plus 2, we went to the right on the x-axis, which is the positive x-axis. Now we have to go on the negative x-axis because the x-coordinate is negative. So we go to minus 1. And the y-coordinate is 3, so we go to the number 3 along that x-coordinate. So we arrive at this point. So that's our point minus 1, 3. So again, we will mark that with a cross. So the point here, this particular cross point here, has an x-coordinate of minus 1 and a y-coordinate of 3. So that point is minus 1, 3. So it's minus 1, 3. Okay, so similarly 5, 5, again 5 on the x-axis and 5 on the y-axis. So we have till 4 here. 5 is the next number along the positive x-axis. So we'll have 5 over here, and similarly 5 on the y-axis will be this particular point. So we go 5 steps on the x-axis and from there 5 steps on the y-axis. So that will bring us to this point, and that corresponds to 5, 5, which is this particular point over here, and we'll write that as 5, 5. So clearly we can see now from this point, if we draw a line to the x-axis, it meets the number 5 on the x-axis, and if you draw a line to the y-axis, it meets the y-axis at 5. So the x-coordinate is 5 and the y-coordinate is also 5. The next point we have is minus 2, minus 3. So on the x-axis, it's minus 2, and on the y-axis, it's minus 3. So y-axis negative numbers are on the downward side. So on the x-axis, we go to the left to get to the number minus 2. And on the y-axis, we go downwards to meet the point minus 3 here. So minus 2, minus 3 will be this particular point over here. So we'll mark that with a cross. And the coordinates for that point is minus 2, minus 3. So we have the x and y coordinates for this particular point, which is minus 2, minus 3. And finally, we have the fifth point, which is 4, minus 2. So that means the x coordinate is 4. So we go on the x-axis to 4. And the y-coordinate is minus 2, so we come along the negative y-axis, so which is in the downward direction. So that's minus 1, minus 2. So 4 on the x-axis and minus 2 on the y-axis. That brings us to this particular point. So we'll mark that here. So that's the point corresponding to 4, minus 2. So I'll write that 4, minus 2. So the x coordinate is 4. So from the point, if we draw a line to the x-axis, clearly it meets the x-axis at 4. And from the point, if we draw a line to the y-axis, it meets it at -2. So we have the y-coordinate as -2. So that's the point for corresponding to the coordinates 4, -2. So now we have seen how to mark the points on the coordinate plane when we are given the x and y coordinates, or conversely, if we are given a point on the plane, we can obtain their x and y coordinates by looking at the line that from the point to the x-axis, and by looking at the line from the point to the y-axis, we can determine what are the x and y coordinates. Okay, so we have seen how to mark the points on the coordinate plane. Okay, so far we have seen how to mark the points on the plane, but sometimes the points may also lie on one of the axes. What if a point lies on the x-axis itself? And what if a point lies on the y-axis itself? How do we mark the coordinates of such points? Let us see with an example. So we have our x and y axis. So this is our x dash x and y dash y. That's the vertical number line, y dash y. X dash x is the x-axis, y dash y is the y-axis, and we have the origin in the middle, and we have the numbers. So on the positive x-axis, that's 1, 2, 3, 4, 5, and so on. Similarly, on the positive y-axis, that's 1, 2, 3, 4. On the negative x-axis, it will be -1, -2, -3, -4, and so on. And on the negative y-axis, we will have -1, -2, -3, -4, and so on. So suppose a point lies on the x-axis. Let's say the point lies at this particular point, okay, at the number 3 on the x-axis itself. What are the coordinates of this point? So first of all, what is the x-coordinate of that point? The x-coordinate is the distance of that point along the x-axis from the origin. So from the origin, you can clearly see that the distance of the point is +3 because it's on the right-hand side of the origin along the positive x-axis, and it is lying at the point 3. So therefore, the x-axis is the x-coordinate for this point is 3. So let's write that. So the x-coordinate for that point is 3. And what is the y-coordinate here? Clearly, there is no distance corresponding to the y-axis here. So what we notice is that the y-coordinate, if we draw a line from the point to the y-axis, it meets the y-axis at 0, at the origin. So that means the y-coordinate for this point is 0. So when a point lies on the x-axis, or for that matter, any point that lies on the x-axis will have its y-coordinate as 0. So it has only the x-coordinate. The y-coordinate in this case is 0, because if we draw a line from the point to the y-axis, it meets the y-axis at 0, so the y-coordinate is 0. And the line from the point to the x-axis, there is no line here because the point itself is lying on the x-axis, but the point is lying on the x-coordinate of 3. So therefore, the x-coordinate for that point is 3, and the y-coordinate is 0. So any point that lies on the x-axis, that is the horizontal axis, will have its y-coordinate as 0. So let us make one more point. Let's say I mark a point over here. Okay, so what will be the coordinate of this particular point? The coordinate for the x-axis is -4, so the x-coordinate will be -4, and the y-coordinate, again, along the y-axis, there is no shifting of the point along the y-axis. It is lying on the x-axis. So when we draw a line from the point to the y-axis, it will meet the y-axis at the origin. So therefore, the y-coordinate is simply 0. So like this, we can mark any point along the x-axis or on the x-axis, in which case any point that lies on the x-axis will have its y-coordinate value as 0. So if you have a point here, that will correspond to -1, 0. If you have a point over here, that will correspond to 5, 0. So the x coordinate will be 5 and the y coordinate is 0. So if you have a point here, it will be 1, 0, and so on and so forth. So any point that lies on the x-axis, its y coordinate is equal to 0. Similarly, if we have a point lying on the y-axis, so let's say this is our point which lies on the y-axis. So here in this case, what is the x coordinate? So if you draw a line from the point to the x-axis, it meets the x-axis at the origin. So that means the x coordinate is 0 and the y coordinate for that point, that means the distance of the line from the origin in the y direction is 3. So therefore the y coordinate is 3. So x coordinate comma y coordinate, x comma y. X is 0, y is 3. So any point, again, any point that lies on the y-axis will have the x coordinate value as 0 and the y coordinate will be whatever number on the y-axis at which the point lies. So in this case, the point lies at the number 3 on the y-axis, so the y coordinate is 3. So if I have another point on the y-axis, let's say here, so what will be the coordinates for that particular point? The coordinate is the x coordinate is going to be 0 because the point lies on the y-axis. So any point that lies on the y-axis will have its x coordinate as 0 and the y coordinate in this case is -2 because the number on the y-axis at which the point lies is -2. So it's 0, -2. So in this way we can have any point along the any point on the y-axis. So again, if I have, let's say, a point here on the y-axis at this number 2, that means the y coordinate is 2 and the x coordinate is 0. So the point will be 0, 2. Or if you have a point here, it will be 0, -3, and so on and so forth. So when we have points on the x-axis, the y coordinates will be 0, and when we have points on the y-axis, then the x coordinates will be 0. Now, what will be the coordinates for the origin itself? So if we have a point lying exactly on the origin here, that is the origin O, what are the coordinates of the origin? Coordinates of the origin, what is the x coordinate for the origin? There is no shift along the x-axis from the origin. So the distance from the origin along the x-axis to the particular point is 0. And similarly, the distance of the point along the y direction is also 0. So the x coordinate and the y coordinates are both 0. So the origin is given by the coordinates 0, 0. Okay, so let's write that. Let me write coordinates of origin are 0, 0. Okay, so the x coordinate is 0 and also the y coordinate is 0. So the coordinate, let me write those numbers clearly, it's a bit messed up. Okay, so we have the x coordinate and y coordinate both equal to 0 for the origin. Okay, so we have seen how to mark points. The points may lie on any of the quadrants, the first quadrant or the second quadrant or the third quadrant or the fourth quadrant, and the points may also lie on the x-axis or on the y-axis. If the point lies on the x-axis, then the y coordinate will be 0. If the point lies on the y-axis, the x coordinate will be 0, and the coordinates corresponding to the origin is 0, 0, because the origin lies on the x-axis as well as on the y-axis. So because it lies on the x-axis, the y coordinate is 0, and because it also lies on the y-axis, the x coordinate is 0. So the coordinates of the origin are 0, 0. And one final piece of observation that we make when we mark the points in the coordinate plane is that let us look at our example that we saw earlier, where we had these 4 points, point B, point M, point L, and point S. Where is the point B lying? It is lying in the first quadrant, or quadrant 1. So we call this as quadrant 1. the point M is lying in the quadrant 2. The point L is lying in quadrant number 3, and S is lying in quadrant number 4. Okay, so what we notice is that when we have a point in quadrant number 1, we see that the x coordinate and y coordinate, they are both positive. So x coordinate is +4 and y coordinate is +3. So that what we notice is that any point that lies in quadrant 1 or the first quadrant will have both the x and y coordinates as positive numbers. So in quadrant 1 we will have the x coordinate as a positive number and also the y coordinate as a positive number. So it is plus comma plus. X is also plus, y is also plus. Next, you see in quadrant 2, you notice that the x coordinate is negative and the y coordinate is positive. X coordinate here is -3, y coordinate is +4. So for the second quadrant, the signs of the coordinates will be negative for the x coordinate and positive for the y coordinate. It's minus comma plus. For the third quadrant, we see that both the coordinates are negative numbers. The x coordinate is negative and the y coordinate is also negative. So therefore, for the third quadrant, the sign of both the coordinates will be negative. That's minus comma minus. So that will be for the third quadrant or quadrant 3. And for the fourth quadrant, what you notice is that the x coordinate is positive and the y coordinate is negative. So we'll have it as plus for the x coordinate, comma minus for the y coordinate. So quadrant 1 is plus plus, quadrant 2 is minus plus, quadrant 3 is minus minus, and quadrant 4 is plus minus. So basically it means that for all points that lie in the first quadrant, the x and y coordinates will be positive. Or in other words, if we have given a coordinate for a point, if both the coordinates are positive, that means that point lies in quadrant 1. If the x quadrant is negative and the if the x coordinate is negative and the y coordinate is positive, it means that the point lies in quadrant 2. If both the coordinates are negative, it means that the point lies in the third quadrant. And if both the if the x coordinate is positive and the y coordinate is negative, then the point lies in the fourth quadrant. Okay, this is another observation that we notice. So depending on the sign of the x and y coordinates, we can quickly identify in which quadrant the point will lie. Okay, so for quadrant 1, both the coordinates will be positive. For quadrant 2, the x coordinate is negative, y coordinate is positive. For quadrant 3, both the coordinates are negative. And for quadrant 4, the x coordinate is positive and the y coordinate is negative. Okay, and this is to do with the coordinate geometry chapter. So basically, you will be given some points on the graph and you'll be asked to find the coordinates for that point, the x coordinate and the y coordinate, which is also called as the abscissa and ordinate, and represent in the coordinate form. And sometimes you will be given the points and asked to mark those points on a piece of graph paper. So you should be able to do that as well. And sometimes some of the questions may be like you'll be given the coordinates of the point and asked to determine in which quadrant that point is going to lie. So by knowing the sign convention for each of the quadrants, you should be able to tell in which quadrant that particular point is going to lie. Okay, we'll stop here, and that brings us to the end of chapter 3, which is coordinate geometry, and we'll continue next with our next chapter on polynomials starting from the next